Alright, in this video we're going to take a look at the third worksheet on solubility in the Advanced Grade 9 Science class. It's found on page 76 in your science booklets. As always, don't just watch the video, either pause the video and then try problems as we go, or use it to check the homework that you've already done. This is also a good way to review for tests and exams. So the first few questions 1 to 9, are similar to questions we've done before, so I'm just going to do a couple of them to review. Why don't we jump in and try question number 2, and then we'll also try question number 7. Okay, so 2 and 7 we'll do together here. So number 2, what mass of potassium nitrate, KNO3, be sure you know the names and formulas for these salts, can dissolve in 175 milliliters of water at 10 degrees Celsius. So to do this kind of question, we need to refer to the solubility curves sheet, which is on page 115 in your science booklet near the back. You also have this on our website if you need it. It's a graph that shows temperatures in degrees Celsius on the x-axis and solubility of different compounds on the y-axis measured in grams per 100 mils of water. The different substances themselves or formulas are found on the side here, so KNO3, that's the one we're talking about in this question, potassium nitrate, sodium nitrate, etc., all the way down to ammonia, which is here at the bottom, NH3. So we're looking at potassium nitrate, and that's this curve here that drops dramatically on the graph, and our temperature was 10 degrees Celsius. So what I'm going to do here is go to 10 degrees Celsius, and I'm going to see what the solubility of this salt was. So at 10 degrees Celsius, the solubility is between 20 and 25 for the potassium nitrate, and it's actually a little closer to 20 than to 25, so I'll say 22 grams per 100 milliliters of water. So let me just put a title down here. So this is more solubility problems, sheet number 3 in your booklet, and again that's on page 76. So what we're doing is question number 2, and the first thing I want to see in your answer is a statement of the solubility. So at 10 degrees Celsius, the solubility of the potassium nitrate is 22, I think we said, grams per 100 milliliters. So there's the solubility. Now the question said, what mass of potassium nitrate can be dissolved in 175 mils of water at 10 degrees? Well, if we had 200 mils of water, then clearly we could have dissolved twice this, right? So instead of 22 grams per 100 mils, 44 grams, it would have been dissolved in 200 mils. We've got 175 milliliters, so the answer is going to be less than 44, probably in the high 30s, maybe around 40, something like that. But let's set up the answer. We're going to use a unit multiplier. You have to use unit multipliers to set up your answers here. So we'll start with the volume that we were given, 175 mils of water. And then we're going to use that solubility that we just found as our unit multiplier. We'll get rid of the milliliters of water, and we'll find how many grams of potassium nitrate can dissolve in there. The solubility was 22 grams for every 100 mils of water. So now, grabbing a calculator, we'll simply take 175, multiply by 22, and divide by 100. So we're going to get, as we expected, close to 40. I'm going to keep 2 digits because the number 22 here has 2 significant digits. So 38.5 becomes 39 grams of potassium nitrate. And then we just want to put a little statement with that. So what I'll say underneath is 39 grams of potassium nitrate can dissolve in, the volume we had was 175 milliliters of water at 10 degrees Celsius, because our solubility was from 10 degrees Celsius on that graph. Alright, the second question we'll do is question number 7 on the sheet. what volume of ice water would we need to dissolve 10 grams of ammonia, 10.0 grams of ammonia? So question number 7, ice water. Well, ice melts at 0 degrees Celsius, so ice water is at 0 degrees Celsius. So at 0 degrees Celsius, the solubility of, now it said ammonia is NH3, it's a gas, and so on the chart here, the ammonia, the only gas that's on this chart, is the one whose solubility drops with temperature, with raising temperature. So we remember that for gases, at higher temperatures, they are less soluble. For salts and most solid substances, at higher temperature, they're more soluble. So the ammonia is a gas, it's the one that's dropping. We're in ice water, so 0 degrees Celsius on our x-axis, and we go straight up to the ammonia curve, and it looks to be just below 90. So I'm going to say 89 grams per 100 mils. 89 grams per 100 milliliters of water. And again, those units are the units that are here on the y-axis, grams of substance per 100 mils of water. Now, the question here said that we have 10.0 grams of ammonia, so we'll start with that, 10.0 grams of ammonia, and we're wondering how much of this ice water should we use to dissolve that. So we're going to again use the solubility. This time we'll get rid of the grams of ammonia by putting that on the bottom like that, and we'll find milliliters of water by putting it on the top of the multiplier like that. So the grams cancel and we're left with milliliters. I didn't do that earlier, but milliliters of water canceled, giving us grams of potassium nitrate back in question 2. So now the solubility was 89 grams, so the 89 will go on the bottom beside the grams for every 100 mils of water, so the 100 goes beside the volume of water. And now grabbing a calculator, 10.0, or just 10 on a calculator, times 100 and divided by 89 is 11.2, and I'm going to keep 2 significant digits, again because 89 has 2 significant digits. 10.0 over there had 3 digits. When multiplying and dividing, we keep the smallest number of significant digits. So we'll say that the answer here is 11 milliliters of water. And now a little statement to go with this. So 11 milliliters of water are needed to dissolve 10.0 grams of ammonia at 0 degrees Celsius, or in ice water. Okay? Now, let's jump in and we're going to try question number 9. Question number 9 says a student wants to prepare a solution by dissolving 70 grams of the sodium nitrate, that's our solute here, in 45 milliliters of water. To what temperature must she heat the water to do that? Now the question suggests, just from its wording, that if the student tries to do this at room temperature, they won't be able to make the solution, so they have to warm it up in order to do that. Let's see why. The first thing I'm going to do there, since I know the mass of sodium nitrate and the volume of water, I'm going to calculate the concentration of the solution that the student is trying to make. So question number 9, concentration, we have a formula for this, is equal to the mass of the solute, in this case the mass of the salt, divided by the volume of the solvent, in this case volume of water, and multiply that by 100. So if we think about the solution the student was making, they had 70 grams of sodium nitrate, so 70 grams of sodium nitrate, and they were trying to dissolve that in 45 milliliters of water times 100, so that our answer will be in grams per 100 milliliters rather than just grams per milliliter. So 70, grabbing a calculator, 70 divided by 45 and times by 100. The solution that they're trying to make will have a concentration, and I'm going to keep one extra digit here. Technically, I should have just two significant digits, but I'm going to round that off and just call it 156 grams per 100 milliliters. So that's the concentration that they're trying to make. Now, the question is, to what temperature do they need to heat that? If I look at my solubility chart, and we find sodium nitrate, that's this curve here, the one that rises up here, and we find the concentration, or actually, why don't we start by just looking at room temperature, 20 degrees Celsius. If we go up to that chart, 20 degrees Celsius, the solubility of sodium nitrate is between 85 and 90 grams per 100 mils, probably about 88. Well, there's no way to make a solution whose concentration is 156 grams per 100 mils if the solubility is only 88 grams per 100 mils. You wouldn't be able to dissolve all of that salt in the water. So the solution to the question here, or the solution to this problem, is to heat up the water, because notice as we heat it up, the solubility increases. Our concentration that we're looking for is 156 grams per 100 mils. So if I just find 156, which is right about there on the graph, and then go straight over to the sodium nitrate curve, which takes me to right about there, and then go straight down to the temperature axis, so straight down to the temperature axis, and we get a temperature of about 85, 86, 87 degrees Celsius, somewhere in that range. To show that in my answer, I'm going to just sketch my solubility curve. I'll put temperature on the x-axis, solubility on the y-axis, and this is in grams per 100 mils. And what we're doing essentially is asking, when is the solubility equal to the concentration that we're trying to make? So find 156 on the y-axis. Our graph for sodium nitrate looks something like that. And so we're going straight over to the graph, boom, and then straight down to the temperature axis, boom, and we're looking at what that temperature is. That temperature, again, that we just saw was about 85, 86, 87, somewhere in that range. I'm going to say about 86 degrees Celsius. So we'll say at 86 degrees Celsius, the solubility equals 156 grams per 100 mils of water. Therefore, heat up to about 86 degrees Celsius. There's the answer to the question. If they heat up higher than 86 degrees Celsius, that will also work. But if they heat up below 86 degrees Celsius, any temperature below that, and the solubility is less than 156, they wouldn't be able to dissolve all of their salt. So there's the solution to the question. Find the concentration. Use that concentration as your solubility, and simply ask what temperature will the solubility equal that concentration. That's the temperature you need to heat up to dissolve all the salt. All right, question number 10 is a multi-step problem. Actually, I'm going to do question number 11, I guess. It's very similar to number 10 and to number 12. They're all multi-step problems. I'll do number 11. A student dissolved 710 grams of sodium nitrate in 600 mils of boiling water. You remember boiling water is at a temperature of 100 degrees Celsius. So then we're going to do 5 basic parts. In part A, it says use calculations to show that the solution is not saturated. Well, that's similar to what we just did. So question number 11, just move my book over here. Question number 11A, since we were told the mass of the solute and the volume of the water, we're going to calculate the concentration. So concentration again is mass of the salt, mass of the solute, divided by the volume of the solvent, the volume of the water, times 100. So in this case, 710 grams of sodium nitrate dissolved in 600 mils of water. And again, we times by 100 just so that the answer comes out as grams per 100 mils and not just grams per milliliter. So now on my calculator, 710 divided by 600 times by 100, and I get 118.3. I'll just round it off to 3 digits, 118 grams per 100 mils. So show that the solution that the student has made is not saturated. Well, we're going to look on our solubility chart. The water was boiling, so we can say at 100 degrees Celsius, the solubility of sodium nitrate is, and pause the video if you want to look that up yourself. So sodium nitrate is right here. 100 degrees Celsius is that temperature right at the very end of the graph. So the question is, what is the solubility? So 100 degrees, we are right around 180, or maybe a little bit higher, maybe 181. I'm going to say 180 grams per 100 mils. Remember, on a test, you'd be allowed to be plus or minus 1. So if I say 180 and you said 179 or even 181, that would be fine. You'd get full marks for that. So how does this tell me if the solution was saturated? Well, since the concentration (118 grams per 100 mils) is less than the solubility, which was 180 grams per 100 mils, the solution is not saturated. There's two other possible situations. It's possible that the concentration was equal to the solubility. If they were equal, then the solution would have been exactly saturated. Okay? Could not dissolve any more than that. The third possibility is despite what I just said, is if the concentration happens to be larger than the solubility. It's a very rare situation. It's called a supersaturated solution, and it's highly unstable. You've managed to dissolve more than you should have been able to, and the solution's just waiting to precipitate the extra salt that dissolved and bring it back down so that the concentration is equal to the solubility. But it is possible to have a concentration higher than the solubility. In that situation, you have what's called a supersaturated solution. All right, part B, we're now going to go through a series of, well, how could you make the solution saturated? In part B, what mass of salt must we add to make the solution saturated? So, what we're going to do here is note that we're adding more salt, and what we want to observe is that when you add salt, the volume of water, not the volume of the solution, but the volume of the water in the solution, is not changed, does not change. The reason I want to note that is because now I'm going to take the volume of water that was used, 600 milliliters, and I'm going to use that as the starting point in a unit multiplier. So 600 mils of water, and I'm going to use the solubility that we just saw, 180. So I'm going to get rid of mils of water, and I'm going to find grams of sodium nitrate, 180 grams for every 100 mils of water. And now grabbing my calculator again, clear the old stuff. 600 times 180 and divide by 100, I get 1080. Now I want 3 significant digits, so now I'm going to just switch that to scientific notation. 1.08 times 10 to the 3, and since the volumes have canceled, what we've just calculated is the mass of sodium nitrate. It's many grams of NaNO3. Now what would be a reasonable statement to go with that? What exactly have we calculated there? Well, 1.08 times 10 to the 3 grams of sodium nitrate can be dissolved in 600 mils of water and this was at 100 degrees Celsius. So by using the solubility and the volume, we've just found how much salt could have been dissolved. But remember, the student actually dissolved 710 grams. That's how much they actually dissolved. And we've just found that they could have dissolved 1,080 grams, 1.08 times 10 to the 3. So if we take what they could have dissolved, 1.08 times 10 to the 3 grams, could have dissolved, and we subtract 710 grams, which was already dissolved, the difference is how much more we can dissolve. Now, if you want to write 1.08 times 10 to the 3 as 1,080, that's fine. But remember, you have a scientific notation button. On this calculator, it's this button here, times 10 to the x. On other buttons, on other calculators, it will be an EE button, so a button that says EE, or it'll be a button that says EXP. Those are scientific notation buttons. So on this calculator, it's actually got a button that says times 10 to the x, which is rather rare. You don't see that very often. So I'm going to type 1.08, then I push that button, and when I push that button, or one of these two, I say to myself in my head, times 10 to the power of, so times 10 to the power of 3. Okay, now on most calculators, it'll simply say now 1.08 E3, which means the same thing. All right, so that's this number out front, minus 710. So minus 710 equals 370 grams of sodium nitrate. Now what does this mean? If you could have dissolved this much, and we've subtracted what was already dissolved, then this 370 grams can still be dissolved. And when we dissolve this, the solution will now be saturated. Part C asks us to saturate the solution in a different way. Part C says another way to saturate that solution would have been to evaporate water. How much water could we have evaporated? What volume of water? So we're going to now evaporate water to make the solution saturated. And just like before, let's make an observation. If we evaporate water from the original solution that the students made, the mass of sodium nitrate in the solution does not change. The mass of the solution will drop because you're evaporating water, but the mass of salt in the solution does not change. You're not evaporating the salt, you're evaporating the water. So the water's escaping, not the salt. So what I'm going to do now is start with the mass of salt that the student used. Again, to remind ourselves, we look back at the beginning, they used 710 grams of salt. So let's take 710 grams of salt. And again, we're going to use the solubility. So we'll get rid of grams of sodium nitrate, replace with mils of water. And the solubility for every 100 mils of water, there was 180 grams that could be dissolved. Now think about what exactly we're calculating here. So 710 times 100 and divide by 180, what exactly does this number, 394 mils of water, represent? Well, that's where the little statement helps, right? So therefore, 394 milliliters of water was required to dissolve the salt. Did they use that much water? Well, again, look back at the question. They used 600 mils of water, but they only needed 394 mils of water. So there's another way to look at why the solution was not saturated. They used too much water. Since they used too much water, we can evaporate the extra water and make the solution saturated. So how much water can we evaporate? Well, we'll take the 600 mils of water that was used and subtract the 394 mils of water, which was needed. That's how much they actually should have used if they were trying to make it saturated. And the difference is how much water we can evaporate. So 394 from 600 is 206 mils of water can be evaporated. When you evaporate that water, the solution will then be saturated. Its concentration will be 180 grams per 100 mils. Part D, a third way to saturate that solution would have been to try cooling it down. If we did cool the solution down, at what temperature would the solution have become saturated? So let's start this answer by again drawing a sketch like we did before, temperature and solubility. And for sodium nitrate, the graph looks like that. And just like we did earlier, we're going to note what our concentration was. Our concentration was 118 grams per 100 mils. So what I'm going to do is find the 118 mark, which is about, I'll just estimate it to be about there. That was my concentration. And I'm going to go straight over to the graph and straight down like this. And I want to know what temperature that is. When the student made the solution, it was in boiling water, so they were making the solution way up at this temperature. And the solubility up there was 180 grams per 100 mils. Because their concentration was less than the solubility, their solution was not saturated at 100 degrees Celsius. So what we're doing is cooling, the solubility drops, and eventually the solubility will equal 118 grams per 100 mils. Now it doesn't have to. Sometimes you can cool it all the way down to 0 and it still has a higher solubility than your concentration. But in this case, we can cool it down to this point, and now our solubility is 118, just like our concentration. So we just need to know what that temperature is. So let's grab our graph. 118 is just before 120. If we go straight over to the sodium nitrate curve, which is there, and then straight down, we are between 55 and 60, and I think slightly closer to 55, so I'll say 57 degrees Celsius. So therefore, cool the solution down to 57 degrees Celsius to make it saturated. So there are 3 different ways to make the solution saturated. Cool it from 100 degrees down to 57 degrees and it will be saturated. You could have evaporated 206 mils of water, that also would have made it saturated. Or you could have added another 370 grams of salt. Now if you added the salt or evaporated the water, the temperature would have stayed the same at 100 degrees Celsius. You'd have to be using boiling water at a boiling temperature to do that. For part D, the approach is to change the temperature, to cool it down, and the solubility drops down to 118 at 57 degrees Celsius. So if you were cooling your original solution, you would have seen nothing happening as you cool it down to that point. It would have looked like nothing was happening in the beaker or in the flask. But suppose you cool it down even further. Suppose you cool it down below 57 degrees. Well, now your solubility is going to be less than the concentration, and that means you're likely going to see a precipitate. It's possible the solution will stay supersaturated, but more likely you'll see a precipitate. The last part of the question says, if the student were to cool the solution all the way to 20 degrees, what mass of salt would they see as a precipitate? Okay, so they cool it down to 20 degrees. So let's note, at 20 degrees Celsius, what's the solubility of the salt now? Well, again, we grab our graph, 20 degrees, we go up to the sodium nitrate curve, and we're between 85 and 90, a little bit closer to 90, so I'll say 88 grams per 100 mils. So the solubility of sodium nitrate is about 88, I think I just said, grams per 100 milliliters. Now, when you cool it, you will see a precipitate form. So the amount of salt dissolved in the water is changing because it's precipitating. But the amount of water is not changing. The amount of water in your test tube, in your beaker, is staying the same. It's the amount of salt dissolved in the water which is changing. So we can say here the precipitating salt, the volume of water does not change. So the water does not change. So now we're going to start with the water then. The solution that the student used was 600 mils of water. Look back at the beginning of the question to remind yourself of that. 600 mils of water. And what I'm going to do is use the solubility at the lower temperature. So we're going to get rid of the mils of water and put in the grams of sodium nitrate. And think what it is I'm finding here. At the lower temperature, 88 grams for every 100 mils of water is what we just saw. What exactly is this going to represent? So let's take a look. 600 times 88 and divide by 100. I'm going to keep one extra digit here. If you want to round it off and say 5.3 times 10 to the 2, that's fine. I'm just going to say 528 grams of sodium nitrate. Remember, on a test, you're allowed to be off with one significant digit. So having 3 instead of 2 is perfectly acceptable. So 528 grams of sodium nitrate, what does this mean? Can be dissolved in 600 mils of water. At what temperature? Well, since this solubility was at 20 degrees, this is at 20 degrees Celsius. Now think back to the beginning of the question and remind yourself that the student had originally dissolved 710 grams in the 600 mils of boiling water. And we've cooled it down to 20 degrees where they can't have 710 grams dissolved. Now they can only have 528 grams dissolved. So do you see what our last step is going to be? We're going to take the 710 grams of sodium nitrate, which was dissolved, and I'm going to subtract the 528 grams of sodium nitrate, which is still dissolved. That's how much could be dissolved. My writing is dying here at the end of the day. That many grams can still be dissolved. The difference is how much can't be dissolved. So this is what will be the precipitate. This is what will come out of the solution. So 710, take away 528, 182 grams of sodium nitrate will precipitate. Remember that word precipitate means that what used to be dissolved, precipitate, what used to be dissolved comes out of the solution and sinks to the bottom of the test tube, bottom of the beaker, and we see that solid sitting at the bottom. So you originally dissolved this at 100 degrees Celsius. This is how much is still dissolved at 20 degrees Celsius, and so the difference is what was precipitating as you cooled it down. Now that precipitation would not have started until your temperature reached 57 degrees. Once the temperature reached 57, the solution was saturated, so when you cooled it below that all the way down to 20 degrees Celsius, at 20 degrees Celsius, 182 grams had precipitated. So there is a reasonably difficult, several part long question, number 11. Questions 10 and 12 on that worksheet are similar to that, so I wish you luck. The answers will be posted, but not in this full format. So this is to show you how to do the problems, but not just how to get answers, how to set up your solutions and the level of detail that is expected of you. Good luck. If you need extra help, you can always come in, make an appointment and come in before school or drop by at lunchtime to get some one-on-one help if you are struggling with it. Feel free to bring a friend as well.